this audible? Is this better?
Yes, yes.
Can you confirm? Am I audible?
Jonek, your voice is very low.
Why is it low? I don't get it.
Yeah?
Is it getting any better? Is it from your end maybe?
Now it is fine.
Okay, I'll try this way.
Okay, okay.
Sorry, I have not been doing my homework properly. So anyway, Namita's last week's question was still not answered. Sorry. And please keep posting to the forums. I know I was tracking this week, but really catch up to all of them. And anything we cannot solve, we'll tackle it to Madam. This week was the majority of the measures. So from last week we carry out concepts about risk. Then this week we
Your voice is not clear.
The voice is not clear.
Jonek, breaking some disturbance in your signal, sir. Can you again?
Well, my network is not improving. Hello.
Yes.
Is it still cracking or just the voice is low?
Voice is breaking somewhere, that it's some noise like that. Can you use a headphone or something, or you remove that if you're using that?
Using a headphone. I don't have any solution, so can you move forward or? Okay, I just switched to another audio device. Still the same?
Yes, it is not clear what you're saying.
So you can do your part.
Yes. It is audible?
Yes, sir. Yes, sir.
Okay, so I have taken 4 to 5 questions of that assignment. If you have any query, then please we will solve first that, and then I go to the assignment solve. Hello? So I think I will move forward.
Sir, sir, this acrylic or polymer, these are made up of like silica material.
PMA is like organic material.
Like it is made up of made up of from silica.
Uh, Namita, traditional optical fiber is made of the silica. Now for
But sir,
high, yeah.
like how we make the variation in refractive index? Like we have to do some doping in this glass material to make the refractive index variation.
It's depend during the fabrication. Like Kojalski method is used for that synthesis of the material of the silicon.
Okay.
So during that we have maybe doping or some changing the property of material, so it will have the different refractive index.
So, do we have any, any place from which I can see like the fabrication process of optical fiber?
What, any palace?
No, no, fabrication process of optical fiber. Can we able to see is there any material available for that?
Material
Next
is
class.
available. Let me check and post in this chat itself. Give me a second.
Jonek, again your voice is very low.
Yeah, I know. Okay, I'll post in chat.
Yeah. So maybe Namita, next time I will include that also PPT, how to make the optical fiber, one slide for that you.
Okay, sir. Thank you so much, sir.
Okay. So whatever the
Sure.
method we use for fabrication of the optical fiber or some video, we can show that.
Okay, sir. Okay, sir.
So basically cladding is like the material, so we can protect that fiber through the environmental impact. So we need that material which is hard to that harassment to the environment also, that we choose the material like that only. Anyone else, any questions? What happened? So this is a question. A laser diode has a spontaneous emission factor, RSP equal to 10 to the power 27 second per meter cube per, and photon lifetime of 2 picosecond. Against cross of around area of around 1.5 into 10 to the power 90 meter square, confinement factor of 0.2, transparency carrier density of n naught equal to 2 into 10 to the power 3 meter cube, group velocity is 8.3 10 to the power 7, this is Vg. Given that laser is operating below threshold voltage with photon density inside the cavity is 5 into 10 to the power 20 meter per cube. So in this question you have to calculate or find the carrier density difference normalized with respect to threshold carrier density difference. I think someone asked about that, if the carrier density is less than that threshold value, then it is possible. So you can find from this idea that what is the relation between the carrier density and threshold. So if you have to attend the class, then you have to answer that, or if you have any doubt, then I will solve also that. Anything that you cannot understand, group velocity, gain cross section, and that. So these are the cavity, and this has the cross section gain of A, and here the that internal photon density of the cavity is around 5 into 10 to the power 20, and transparency carrier density will how much the density will be travel that from one end to another end, like that from this end to this end, how much the carrier it will take, and group velocity will hold that velocity of that, this is Vg. So one formula I have provided already you in this thing, and if anyone want to, then if you are able to solve, or I have to solve that, please let us know.
So please solve this one.
So this is the P is the power, RSP you have to given, T type, that photon lifetime, that TP is the photon lifetime, that is 2 picosecond, and G is the gain of that photon, that you have to already given. And from gain we have not given, then gain we have to calculate, that gain is given by 1 upon TP minus RSP upon P. From this we have to calculate gain. Okay, because gain we have to calculate. Again you have to given in formula n equal to total carrier density is equal to n into n naught, sorry, n minus n naught equal to, someone is, I have to, 1 minute please, I have to add someone also. So my 1 minute, sorry. So n minus n naught equal to gain upon 2 confinement factor Vg into A. Okay, so you given that n naught, you have to given, you have to calculate G, confinement factor you given, Vg you given, and A you have given. Okay, so
Sir, is this question from module 3 or module 4?
yeah,
Is this question from module 3 or module 4?
in model 3 it is from, we have solved model 3.
Okay.
Model 4 we have to take next week. So if it is so from that you have to calculate that n naught. So threshold gain NTS equal to n naught, sorry, NT minus n naught equal to 1 upon 2 confinement factor Vj into A into carrier lifetime of photon TP. So through which you can calculate that NTS. Okay, from these two formula, from this first formula and this second formula, that G by this, so you have take of that, if you divide both the factor, n minus equation 1 by equation 2, it will give you equation G upon GTS. Okay, so from that you can calculate that carrier density normalized with respect to threshold. So in my case it is come around 0.98. I have solved direct because I have the solution. So it is G upon GTS. From that calculate G equal to 0.9 into GTS. I think you have not to clear that also. I have to clear. So my G equal to 0.98 times GTS. So gain of that optical fiber always should be greater than threshold value. It will be not less than every time. It may be equal, but we have to keep the gain of the that cavity should be greater than the threshold gain. So our carrier will be reached at the end point more than otherwise our carrier will be or so signal will be not reach at the output side. So we have to make sure that gain should be greater than or equal to GTS. Okay. Anyone have any doubt in this? Any formula you have not understand, then let us know. Please, anyone if you have any doubt, then let me know. What happened to this? So I need your from your side suggest the method to increase the resonant frequency. So what is the resonant frequency? Can anyone tell me? Mute yourself and please tell me. Please, Namita. And Anchal, are you there? Himani, Kusagra, Lakshmi, anyone is there who have about the resonant frequency? Not in term of the optical term, or you have to know anyone about the resonant frequency in that. If you have read anywhere in that, you can tell us that. Increase the photon life. Kusagar, what is meaning of that increase the photon life? Namita, are you there?
Sir, yes, sir, I'm here only, but sir, actually, I was busy this week, so I was unable to get into any lectures. Actually, I was going through interviews, so I was preparing for that only.
So, Ravi, are you there? Sheikh Ruxana. So move next. So resonant frequency equal to square root of GNPB upon carrier lifetime of photon
Hello, sir.
minus 1 upon 2. Yes.
Are you sharing the screen, sir?
It is not visible.
No, sir, it's not visible.
So it is visible. It is visible.
Can you log out and again join? It is not visible.
Visible, sir.
Just profile is visible, sir.
What?
Profile is visible, sir.
My profile is visible.
Yes, sir.
Okay, again I will stop and share again.
Now it's so
1 minute, Kalyani.
gone, sir. It's gone, sir.
Now?
So it is visible.
Okay, if someone is not, then I have to take care of also that. Kalyani, it is visible?
Sir, for me, it's not visible, sir. Just profile is coming.
Please, can you log out and again sign up?
Okay, sir.
What happened today? One minute. Now it is Kalyani visible? Hello?
Yes, sir.
For us,
My screen visible?
Screen is not sharing, sir.
Yeah?
You are just the profile, sir.
I think you have to log out that.
Okay, sir, you can continue, sir.
So resonant frequency equal to? It is PB का whole square. All are in square root. So what can be the method should be to increase the resonant frequency? From this formula, can you tell me that what should we can vary so that the resonant frequency will be changed or increase? Not this answer I need. I have to answer one already. I need a group discussion on this. If you have attend the class or you have go through that video of that ma'am already uploaded on that NPTEL, then please answer that. Kusaga told that you have to decrease or increase that photon lifetime TP in chat box. Anyone have else any idea? What happened, guys? I already provide you formula. So you change that, this parameter will be changed, will be increase or decrease that resonance frequency. From formula you have to just transfer that. If you not speak, then this class will be useless for us or for me or that Jonek, and for you also that. So in this case we can increase that power, we can reduce that photon carrier photon lifetime, that how much that photon will take travel to from one end to two end from generated, that we can decrease that also, which will increase the resonant frequency. We can reduce also that carrier lifetime, or we can increase the gain or that power, which will increase that our resonant frequency. These are the four parameter: lifetime, carrier lifetime, or that photon lifetime, gain, and that power. So next question is that you have given that line width enhancement factor of semiconductor laser is 5, and that adiabatic chip coefficient is 20 hertz per watt. Assume that wavelength of the semiconductor laser is 50 nanometer and slope efficiency is 0.45 milliwatt per milliampere. So next question you have to given that dense wavelength division multiplexing grid is space 850 kHz. What is the change in bias current required to move operating frequency across one grid? So have you any idea about that grid and everything? Please. Have you any idea? So my change in frequency delta f1 equal to, in this case, alpha is upon 4 pi. So this alpha is adiabatic self coefficient, you have to given that already. Okay, upon 4 pi into small k into pb1. Okay, so you already know that power in that cavity equal to pb equal to change in power with change in current. Okay, this is I, and into IB1. So again we have to take the ratio of that, delta f same is alpha h upon 4 pi into k into pb into IB2. So we have to check that change in the bias current required to that. So what is the change in frequency? Delta f2 minus delta f1 equal to alpha h upon 4 pi, we have to take k constant, and this one is equal to IB2 into minus IB1, and delta p we have to take constant, delta p delta I. So alpha h, that laser enhancement alpha h you have to given equal to 5 in that case. One more, I have to take it as a If you not understand, then please can you interrupt me in that case also. So alpha h you have to given 5, k you have to given 20, and change in power with change in current you given equal to 0.45. okay, and frequency, that delta ib, that you have to give in gigahertz, that current is equal to like that 50 milliampere. Maybe I have missed that ib, change in current. Okay, so change, I have missed that the data. ib2 minus ib1 equal to 50 milliampere. Please note, sorry for that. So change in frequency equal to delta lambda equal to lambda square c into delta f. So delta f, from you calculate that from delta f minus delta f2 minus delta f1, lambda square you have to given 550 and c you know 3 into 10 to the power 8. So from that you change in the wavelength you can calculate. Find the shift in the wavelength when the operating current changes from 50 milliampere to 100 okay. So you have to calculate shift in wavelength, again that you have to calculate delta lambda. Sorry that I have explained this question that to you, that 50 milliampere to 100 milliampere. So this is ib1 equal to 50 milliampere and ib2 equal to 100 milliampere. Okay, so last time whatever I explained, that is answer of this question only. Sorry for that. Now for that question we have to check that second question, frequency of one grid. So you know that delta L equal to alpha h upon 4 pi into k into change in power delta p. Okay, so change in frequency you given that 50 gigahertz, in that 50 into 10 to the power 9 equal to alpha h you given equal to 5, 4 pi you know that, into k की value you know that 20 into delta p. From that you calculate delta p. Okay, and we know that delta p upon del I, we already know that. So we calculate delta p upon del I equal to dp upon di, through which we can check that change in delta I equal to dp upon di into delta p. So we can calculate change in that current in that. Next question is a gallium arsenic laser operating at a center wavelength of lambda. You have to given lambda center, I given that 800 nanometer, has a 500 micro cavity. Length of the cavity is equal to 5 into 10 to the power minus 6 meter. Has a refractive index n equal to 3.6. If the gain exceeds the total loss only in the region 750 nanometer to 850 nanometer, how many longitudinal mode are possible in the laser? So anyone can tell me what is the longitudinal mode? Have you about where the longitudinal mode? Anyone can answer that? So frequency of resonance is given to that velocity of that frequency c into 2nl. C is the speed of light, n is the refractive index, or L is the length of that cavity. So you have all the parameter here, L, N and R. So it will be around come to 83.5 gigahertz. So we need to calculate the mode. So lambda Vf is the mode of that we have the Vf into lambda square into C. So that center frequency Vf you already calculate, lambda square C center frequency you given, and C you have to already given. So it is already it will come around 0. So lambda Vf you have to, it will come around 0.17 nanometer. So what is the difference between the wavelength, how much longitude move between 750 to 850? We have calculate what is the loss that longitude mode will exit in this range only. So what is the difference of the wavelength is around 100 nanometer, and we have the lambda Vf equal to 0.17 nanometer. So it is around come at 580 nanometer, or between the 580 to 650 nanometer as per your calculation. So if you have any doubt other than these questions, you can ask me, or Jonik will be continue further.
Is my audio getting better?
Yes, Jonik, you can share your slide.
Is my audio all right now? I
Yes,
changed my network and stuff.
yes, it is audible.
Stop me if something goes wrong.
Yes, sure.
We'll review the concept, so we have already covered. Are there any doubts regarding the content of week 3? Really silent class. So, MATLAB is a tool that is very useful to any scientific computing. It's not the only tool, but it's a very popular tool. It will help you in your future if you're like comfortable with MATLAB. So, as a part of this course, NPTEL has arranged a few licenses for MATLAB. You can access those. But MATLAB is not the only software that can do all these things that we want to do. There are other free alternatives also, like Python has some libraries that can give you all of the functionality that MATLAB provides. Also, MATLAB is very expensive. So is LabVIEW actually. A free alternative would be Octave. The syntax and how it works is very similar to MATLAB, but Octave is free. Octave is slower in some aspects, or it doesn't have as many functions, as many libraries maybe. But to learn MATLAB, you can try this free alternative. You can do most of the stuff in MATLAB. Today we will just start with the basics of MATLAB, just to get you acquainted. You won't be required to do a lot using MATLAB during this course. What NPTEL has provided you is a link to this matlab.mathworks.com, and you can log in using your email ID, and it will provide you something like a this is a command prompt for MATLAB, so you can use it just as a basic calculator also. Like if you want to do just anytime you type something, So you can use MATLAB as a glorified calculator also. But the power that comes uh, with MATLAB is the ability to use a matrix in MATLAB. So you can assign your answers to uh, some variables and you can manipulate those. So just as an example, a is equal to 1, we have assigned, then we can do a times something. So you can use MATLAB as a glorified calculator. You can also uh, use multiple elements in a vector to form a vector. Vector can be declared like this. Vectors could be row vectors could also be written as this. This gives the same result. And column vectors going to the next column is done by using semicolon. Like so, D it shows up as a column vector, and you can just like vector multiplication, you can do C times D and get an answer. Now you can see that all of these whatever operations we are doing is showing up in this workspace that will show to your left like this in this uh, web tool. And if you install MATLAB, it will show up something like somewhere here. Like this is the graph we plotted using something we wrote. This is the LED spectrum equation we discussed in week 2. So the workspace is here coming in towards the right, but these workspace is a very useful tool to see how your variables are behaving. We'll get back to the those tools. Um, so to declare a matrix, for example, and which is this is how you declare matrices, and matrix times vector calculations happen like I don't know what column vectors do you have? D using column vector. You can do these calculations. Also, MATLAB has all of these inbuilt functions also, like sine or cos you want, pi times is pi. This is a very small value. This essentially zero, but due to rounding error, it's not exactly zero. So be careful about this. So this is how you can use it as a calculator or just matrix and vector operations. But you can also uh, use it to plot functions and do graphical things. For example, I am declaring this uh, array f that goes from 0 to pi in steps of 0.01. So this will declare an array and this will make a huge mess in the screen. It will try to display all of the elements. So this is like 315 elements. It is showing all of them. If you want to suppress these, you can use this semicolon to suppress it. So it does the same operation, but it doesn't clutter your screen. If you just want to, we'll go ahead. And for example, as a function of x, you have sin x. Now, this input x is a vector. You should be careful about this. So we can declare y equal to sin x, and we can go ahead and plot this. In the web tool, it will show up as a different panel. What's the problem does it longer? Let me review the last step. So we have just shown for sine that you are not limited to just sine. You can plot any function you want. So anytime you encounter some new expression in the course, instead of plotting it by hand or analyzing it, you can just uh, come to MATLAB and plot everything. You should be comfortable with that. And in the same plot, you can plot other functions also by saying it to plot in the same plot and then you plot cos x on top of it. Sine and cos are both are displayed in the same plot. So you can find intersections roughly by just hovering over the point. This is essentially what will be asked in week 5. What else I wanted to discuss? You can specify the type of plot by using other arguments. But how do you know what arguments to use? You should be, whenever you encounter some new function, you can always ask for help for that function. MATLAB has a lot of functions. You don't need to know all of them. Anytime somebody asks you to use something, you can just go to help. This a better formatted version is also available in the web. You can just Google a function, a MATLAB functions plot. It will take you to MATLAB documentation. So this documentation is very good for MATLAB. And anytime you encounter some new variable, you can use it. MATLAB itself is under alternative because of the toolboxes that it allows. For this NPTEL course, we have signal processing toolbox and serializer, deserializer, and a few other toolboxes that are enabled in your. So, for example, you can take a FFT of a function. Say, let's take kind of. We have take two spikes. We have one or two. So, if we go ahead and plot this, we're plotting the magnitude of the FFT. See, that instead of having two spikes as you expected, near zero, it is giving some spikes at weird positions. That is because the frequency values from zero to essentially uh, configured by half is actually plotted before in FFT as compared to uh, the Fourier transform that we are actually the continuous time Fourier transform that we are usually interested in. So you can rearrange this FFT output using functions such as FFT shift. It's available in and now if you go ahead and stop it. And it didn't save FFT shift. If you try to zoom the workflow is much slower, you can also install this in your system. Just keep it and let it go. Amplitude of FFT on
So, what is the difference between absolute and normal floating curve?
absolute means FFT results are all complex values. Right? We're trying to only take the magnitude, but we don't have to care about this.
Okay, sir.
We just want to then observe it. This is just a basic to show the capabilities, how MATLAB is capable of. This is a simulation of a transmission line. We connected a sinusoid source here. Voltage and current are solved using partial differential equations. The couple differential equations, we saw those in this laser lectures also. So you can see the standing wave. MATLAB can do this just like logic. This I ran once. The LED frequency response we covered in V2 would graph like this. This is plotted in MATLAB for three different samples. MATLAB can do that. This is a simulation of a 3DFK system. The symbols show up like this, and the frequency response, the this is in log scale. initial response looks something like this. So when you say for 1 gigahertz PCSK signal, we assume we only assume the main load, this one. The main load will come to for 1 gigahertz to peak, it will come to 1 gigahertz at this point. These side loads are usually 20 dB or more lower. So usually ignore those. When you say this is for 32 GB, okay, 64 GB plus PPSK. So the bandwidth is 64 GB only considering the main load. You can simulate those. Yeah. And this is a simulation of the entire simplified chain of this fiber. We are using Alexander modulator that you will see in this course, passing it through a dispersive fiber. Dispersion you will learn in week 5 or 6. We are detecting it using a noise detector that you will learn this time as well. Then plotting a VR versus MR curve. We can, yeah, so due to the fiber dispersion, the bit error rate doesn't go as low as it would have without the fiber. This is a simulation for that. So you can make these codes available to you. You can go to them maybe, but it's not necessary. For this course, we do want you to get just acquainted with this thing because it's very useful. If you have any problem with installing MATLAB, etc., you can also try this Optic. Click this. It follows all of the syntax of MATLAB. This MATLAB code runs on Octave without any editing. If you don't use any specialized toolbox, the same can also be done in Python, but Python runs approximately at half the speed of MATLAB. Like you have to do a lot of scripts to make it run quickly. So anything MATLAB can do, Python can do as well. Get comfortable with at least one tool out of these two. This is just a basic introduction. You can revisit MATLAB later, maybe you can improve as well. So this was a basic intro. Make sure you install MATLAB or use a web tool also, it's also fine. And there are a lot of tutorials available about MATLAB. Don't be limited to this. Get comfortable with MATLAB, use YouTube, whatever web resources you can. Right. So some constellation diagrams for different noise levels. I think one student asked this question about why don't you use negative F? You can see that the clumps are very overlapping, so it becomes difficult to decode. But there are very to recover signals from this. For example, CBMA signals will look like this. Very noisy, but coded pulses can help you recover very noisy signals. Eye diagram. Whenever SNR plot you must have seen other places. It's a very common plot you might be seeing again and again, multiple plots. This is the basics of MATLAB I would say.
I have one doubt. Can I ask?
Okay.
So, tell me one thing. Like, earlier we used to work in 800 nanometer window, 850 nanometer window, and the attenuation is 5 dB per kilometer. So, So please tell me, like in 1 kilometer, how much power get reduced? Like if the power is 10 watt, like how much power is reduced? Like if I work in first window.
Could you repeat? I missed a little part.
So like
800.
we have
Yeah, yeah.
like we have first window on 800 nanometer. The attenuation is 5 dB per kilometer. So, I just want to know, like, if I'm having the input power of 10 watt, then how much power is reduced in 1 kilometer?
Right. For this.
So, can I not write it down so that we will able to see?
Namita, you now ask your text on that message box.
On next session, should I ask?
No, no, not
No,
you
no, no.
can
It's fine.
text
It's
it.
fine.
You can text it. In call message you can text your doubt, so he will understand more about.
No, just 5 dB per kilometer. How much is the actual attenuation? That is the question.
I think he asked that Jonek how much the power loss in that after that what kilometer.
Yes, sir.
So it on 100 kilometer or at distance how much?
So, like per 1 kilometer, I'm just asking in 1 kilometer, like if it is 5 dB, 5 dB means how much power we get lost. Like we talk about 3 dB means power is reduced by half.
So if we calculate the power loss in that optic cable fiber, we have to take care of the some parameter. I think Jonek that again and
My
that
what? Yeah, my tablet is not working.
yeah.
Why do I write? My tablet is not working.
No, no, it is working.
No, no, my WhatsApp tablet is not working to write on screen. So
Okay.
anyway, I'll show you maybe. Otherwise, Ashok can take it. Wait.
Okay, okay.
So 5 dB per kilometer means, so 5 dB per kilometer is the loss. It will become somewhere. Anyway, so this basically means that 10 times log of log base 10. This is base 10 by the way. 10 log 10 of what is the output power after one
Divide by
after
input
whatever this was
power.
divided by input power. This is the dB. This is the total loss in dB.
Yes, sir.
If you discuss in amplitude, uh, we'll be doing a square of this, which will show up as a 20 log something.
Yes, sir.
So when you're discussing electric fields, you will go 20 log, but dB scale always represents in power.
Yes, sir.
So for 1 kilometer, it is saying that this expression is equal to actually minus 5
Yes, sir. So I got it
loss
because
and
like
gain.
we usually take
Yeah,
P in by gain by P out by P in, but like loss by P in by P out. That's why we written -5 here.
yeah. Uh, Ignore the errors. Anyway. So um, so from this point, you can do algebra to get P out by P in. You want to
Yes,
know
sir.
how much
10 to the
it is
power minus
decreasing, right?
0.5.
Yeah. This is 10 raised to the power log base 10, right? So
Minus 0.5.
yeah. So P out will be 31% of P in.
Okay.
You might
Okay, sir.
also see expressions like e to the power minus alpha L instead of alpha I'm
Mm-hmm.
writing here.
Yes, sir.
So this will also show up as like some 10
So
log
why
something.
we always calculate like OSNR and these attenuation in dB only?
Logarithmic scale usually compresses the y-axis, right?
Mm-hmm.
So even high values show up as manageable numbers. Well, I mean, would you rather handle with 10 to the power 9 and 10 to the power 10 kind of numbers, or uh, they will just show up as like what 90, 100 dBs or something?
Yes, sir.
So numbers are more manageable here. That's the whole reason.
Okay, sir. Thank you, sir. Thank you so much, sir, for resolving my queries. And thank
Anyone
you,
have
also, sir.
anyone have any doubt in that MATLAB? Then Jonak will be solved that. I also post some basic PPT of that MATLAB for starting that also on Classroom. So and
Zona sir, please share this code with us. Like if it is if it is if you are able
Yeah,
to
yeah,
do it.
yeah. It's my code. I can share.
Okay, sir.
so Jonak, can we finish?
I guess. Yeah.
So no one have a doubt. So thank you for everyone. So we meet on the next week on Tuesday same time. And please post your question on that ask to question on that SWAM portal if you have any doubt. And you can post us on the Google Classroom also that wherever you feel possible that feasibility that. But most probably you can ask to on that ask to question that on that Google form discussion that on that classroom that on SWAM portal.
So I know I have been lagging a little bit this week, but all of those questions will be answered. And anything we have doubts on, we will escalate to madam. So
Yes,
don't
yes.
worry. Let's keep posting there.
Okay.
Zona
Okay.
sir, my answer is pending remains. So I think I'll
Yeah.
able to get my answer by next week.
Yeah. I promise. Yeah.
Okay, sir. Okay, sir. Thank you so much.
Okay. Okay. Thank you.
Thank